Hi everyone, my GSoC project is on improving the Decompiler widget. My name is NIRMAL MANOJ. I'm a second year CS undergraduate student at IIIT Hyderabad in India. First of all, R2 and Cutter do not have a standard decompiler interface. Having a decompiler interface that is uniformly used across all the decompilers that Cutter supports can be very useful. Earlier, Cutter was using a custom structure named annotated code or something similar, but that was simply not enough. I've also improved R2 Git redact to better annotate decompiled code, but more on this later. Earlier, the decompiler in Cutter did not have a dedicated decompiler context menu. Every portion of the decompiled code is mapped to a certain instruction in the disassembly using offset annotation. Exploiting this, the decompiler widget was using the disassembly context menu, whereas if you right click on something in the decompiler, it will open the context menu for the corresponding instruction in the disassembly. I also made several other improvements to make the decompiler more responsive and stable. And apart from all these things related to the decompiler, I've done some other things like the extras for local variables in the disassembly context menu, but I won't be talking about those things again, as I want to focus on the decompiler. Even though R2 did not have a standard decompiler interface, a structure named R annotated code and a lot of useful API was already present in R2 Git redact. So I shifted this API to R2 properly, or using it as the standard decompiler interface. I also made some API for the context sensitive annotations which were not really present in R annotated code at the time. This is the structure of R annotated code, and code stores the decompiled code, and annotations is basically a list of all the annotations for the decompiled code. We have 7 different types of annotations, and the offset and syntax highlight annotations were already present. And offset annotations, as I mentioned before, represents the address of an instruction in the disassembly that correspond to a part of the decomiled code. And syntax highlight is basically used for syntax highlighting purposes. And the rest of the 5 annotations are context related. So we have an annotation for function name, global variable, constant variable with an address, local variable, and function parameters. So for function names, global variables, and constant variables, the required data is contained in a structure named reference, and the offset will contain the address of these references, and the name is available only for function names. For local variables and function parameters, we store the name in a structure called variable. This is a JSON representation of all the different kind of annotations that we have. This is a function name annotation, and the start and end basically represents the position of this function name in the decompiled code. The name gives the name of the function, and offset gives the address of this function. Similarly, for global variables and constant variables, offset gives the address of them. For local variables and function parameters, we have the name, and the name of this local variable is count limit. The name of this local variable is HS. I mean, this is a function parameter actually. All of these things that I've talked till now lay the groundwork required for making a dedicated decompiler context menu, and in turn, a more responsive decompiler widget. So without further ado, let me introduce the new decompiler. The sync unsync mechanism has been implemented for the decompiler. If you want to toggle sync, you could right click and then choose this. Now if I go to this function, it won't get reflected in the other widgets. If you want to sync back, you could right click and choose this, or you could also right click here then choose sync. Now as you might have noticed already, we have 3 instances of the decompiler widgets, each with its own decompiler. This one has redact, this one has Ketra, and this one has redact. Now if you want to add a new decompiler widget, you could go to Windows and choose add decompiler. You can also choose the decompiler widgets from here for that new widget. Now let me show you some cool actions that are available in the decompiler context menu. If you want to add a command, you could right click and then add command. Let's say articon is here. In order to edit the command, right click on the command and then choose edit command. To delete the command, you can just right click on the command and then delete command. If you want to rename a function, click on it and then choose rename function. Let's say I want to rename this function to articon function. Now I'm going to show you the show in action. The show in action basically shows this line of decompiled code or the address that's corresponding to it in a different widget. For example, if I'm opening this articon function in a new graph, you can notice here that the seek of this graph widget is a call articon function, and that's precisely what this line of decompiled code is doing. And we have one more type of show in action called the targeted show in action, and this is available only for references, and in this case that reference will be opened in a new widget. For example, if I choose a new graph from the targeted show in action, you can see that the articon function has been opened in a new graph widget. I'm going to open a new decompiler widget for articon function. Here we have a global variable. In order to give a name to this global variable, you could right click and choose add name. Let's say hello. As I mentioned before, the show in action, actually the targeted show in action is available for all kind of references. So if you want to see the hello in a different widget, you could go to show hello in and let's select disassembly. And this is the address of the global variable named hello. You could do the same with this string as well, as this is a string literal with a constant address. Here you can see the string hello. Now if you want to rename this global variable, you could right click here and rename this to, let's say, some random things. Yeah, and if you want to remove this variable, you can right click and then remove cutover. Let's say you want to see the references to this global variable. Here are two references to this global variable, and if you right click on this reference and then show it in a decompiler, that reference will be opened in this decompiler. You can also see extras to functions. In this case, you can see that we have two references to this function named articon function. Now let me show you some actions related to the function variables. Let's say I want to edit this variable. I could right click and then choose edit variable. I'm going to rename this to str, and I'm going to change the type to char star. If you want to rename a local variable, you can just right click on it, then choose rename. Let's set array 2. There's a catch here. The actions related to the function variables are available only for those variables that are defined in the disassembly. For example, if you look at this variable, you can see that it's not a part of the disassembly here. And as a matter of fact, this is a GitHub generated variable, so you can't rename this. And if you try to rename this using the shortcut, you will see this warning widget, for example. And the actions are disabled in the context menu as well. Now let me show you some actions related to the breakpoints. It's quite natural to have multiple instructions in the disassembly getting mapped to a single line of decompiled code. So in this case, this part of this line is mapped to this instruction, while this part is mapped to this instruction. But if you add a breakpoint to this line, it will get added to the earliest offset in the decompiled line. And if you have multiple offsets, and if you try to remove, you have an option to remove all breakpoints. And if you try to toggle the breakpoint while you have multiple breakpoints on a line, all the breakpoints in the line will get removed. Also, if you have multiple breakpoints in a line, you could go to breakpoint, edit breakpoint, and then choose the breakpoint that you want to edit. Now I have one more set of actions left to show you. They are the copy actions. So as usual, if you right click after selecting something, that will get copied. But if you don't have a selection but you have highlighted something, and if you try to copy, that highlight will get copied. And if you don't have a highlight or a selection, and if you try to copy, the entire line of code will get copied. The one other kind of copy action that we have is the copy instruction address. So in this case, you can see that we have a call articon function in the disassembly that's mapped to this line in the decompiler. So if you copy instruction address, basically this address will get copied. Similarly, we can see here that the address of this function is 4013A3. So if you right click here and then copy address of this function, that'll get copied. And this might even be more visible if you do that with a global variable that is already showing its address. Yeah, so that's mostly what's there to show in the decompiler, and that is probably the end of this presentation. Special thanks to my mentors Itai, Carlis and Florian. Without them, this wouldn't have been possible.